Let's take a field trip to a magical place where there is no gravitational strength and there's no friction due to damping. Here I have on this magical place two objects connected by a spring, and I want to show you what happens. Whoa! Check that out. It's going to keep doing this forever. It's what we call simple harmonic motion. Now, before we can dive into this unit, we have to make sense of some terms, but if you felt good with the circular motion unit, then you should feel pretty comfortable with where we're going with simple harmonic motion. It's very similar to uniform circular motion. In fact, it could be considered like one-dimensional circular motion. And I'll explain more about that connection in the next video, but this video is really just meant to refresh you on some terms. 4 terms: period, frequency, velocity, and angular velocity. So the period is the time it takes to complete one full path. If I start this in motion, it would be like setting my timer here, go, and when it gets back to that point, now that would be my period, the time it takes to go on one complete path. And we could measure this in seconds. We typically measure it in seconds. An expression for this would be the time it takes to make any number of revolutions. N is T over N. Our frequency is just the inverse of that. So it's the number of revolutions in any given amount of time. So if I start my timer and I start counting up the revolutions, 1 revolution, 2 revolutions, and let's say I stop my timer now and that was something like, I don't know, 5 seconds. I could say, well, it made 2 revolutions in 5 seconds, so my frequency would be 5 over 2. I measure that in either revolutions per second, which is the same thing as a hertz, or hertz, and typically you might see this in revolutions per minute. If you do see it in revolutions per minute, it means that we're going to need to do some conversion to get it into revolutions per second, or we might turn over to angular velocity, which I'll describe in a second. But know that the period and frequency are inverse of each other, so if you have the period, you can get the frequency by doing 1 over period, or vice versa. Velocity, straightforward, we've been doing it since day 1. It's the displacement over a time. When you're moving in circular motion, well, you cover 2 pi r, and if you cover 2 pi r in a given period, you can figure out the velocity. And what gave some people some trouble in the circular motion unit was angular velocity, the rate of angular displacement in a given period of time. So if you're talking about the period, the time it takes to complete 1 full revolution, well, in 1 revolution you're covering 2 pi radians. So our expression for angular velocity is 2 pi over period. But since I know that frequency is 1 over t, I could rewrite the angular velocity as 2 pi times frequency. These terms will come up a bunch in circular motion, or in simple harmonic motion, so make sure you're comfortable with them. Until next time, happy physicsing.